Okay, so this entire chapter is about trigonometric identities. That, that pair of words is, it's very common and very well known in math. Trig identities, for short. A trig identity is basically an equation that involves trig functions, right? So when you have two quantities that are the same and you set them equal to each other, that becomes a trig identity. Like, you all know many trig identities already. All of these that you know as, just common sense by now are technically trig identities. Like, you know that sine is the reciprocal of cosine, right? Sine is 1 over cosecant of theta. I'm sorry, cosecant is what I meant. So that relationship is an identity, right? So you already know all of these identities, the reciprocal ones and the quotient identities. So this whole chapter is about how do we use these in order to simplify or solve trigonometric equations. Okay, so here it says to find the indicated values. We're given, you're always going to have something that you're given, and then you have to find something else. Now, again, what I've always said is it's never about the final answer. It's about the process. It's how to show your work to justify what you've done, right? So here, we are given this and we want this. So I say, okay, secant of theta is 1 over cosine of theta, which is just 4 over 3, right? And yes, you could have done it in your head, but, showing this is a way to justify your work. And in AP Calculus, that is all what it's about, right? Okay, so here you have secant of x is 5 over 4, tangent is this. This is the given, and this is what we want, right? So, okay, so I know that cosine of x is equal to 1 over secant of x. So I know that cosine of x is 4 over 5, right? So what I'm given here is secant and tangent, and I want to find sine. I know that sine over cosine is tangent, so I can use that, right? So now I have cosine, and I have tangent. So what do I know about that? I know that tangent is sine over cosine. So sine x is cosine times tangent, which is what? 4 over 5 times 3 over 4. So sine x is 3 over 5. Okay? Now, do you need to show all this? Okay, I get it. This is a simple one. And I will tell you right now, you're never going to get one like this on the test or the quiz, right? And then the ones that I am going to give you are going to be ones that you just have to show work for. But here we're just getting used to manipulating these things. Yeah?
You just draw a triangle.
No. Okay. Well, okay. Yes, you can draw a triangle. Yes, all this can be solved with a triangle. However, in this chapter, we are learning about identities. So you can check your work using a triangle, but I need to see you having solved it with an identity if you want full points. So for the duration of chapter 5, that's what I do. Then when these show up again on the final, you can choose whatever you want. Okay? Okay, so let's do this one. Okay, so when we have a right triangle, right, we know by now that this is the cosine and this is the sine, right? Let's just label those y and x. Why not? Now, what does the Pythagorean theorem say? It says y squared plus x squared equals 1 squared, right? Yeah, we know this. Okay, what's y? Sine of theta squared. What's x? Cosine of theta squared equals to 1, right? Another way of writing sine of theta squared is sine squared theta. Cosine squared theta is equal to 1. Do you see how we derived that? How we came up with that? We used the Pythagorean theorem to come up with that, right? So this is called a Pythagorean identity. Okay? This fact here is called a Pythagorean identity. You need to memorize this. Okay, this is a Pythagorean identity, as it says here. You just have to know this. Okay, now, the Pythagorean theorem identity has friends, right? So let's take the Pythagorean identity here on the bottom of this page. I'm gonna, take this one. Okay, now, just for fun, just because I can, I'm gonna divide through by cosine squared theta. You know why? Because I can. What happens when I do that? Here I have sine squared over cosine squared. What's sine over cosine? Tangent. Sine squared over cosine squared is just tangent squared. Theta plus, what does this business give me? A 1 equals, what's 1 over cosine? Secant. 1 over cosine squared, secant squared theta. So do you see how this is something that we just derived or came up with using this? This is now the second Pythagorean identity. Okay? But now, if we take that sine squared theta plus cosine squared theta equals 1, the Pythagorean, and now we divide by cosine squared theta, what do we get?
Wait, divide by sine.
Right. Oh no, divide by sine squared theta, sorry. Because we already did the cosine. What do I get now? Sine squared over sine squared is 1. Cosine squared over sine squared? Cotangent. So 1 plus cotangent squared theta is equal to cosecant squared theta, and that's the other identity. Do you see that? So you have to know all three of these identities. But nobody memorizes all three, right? You have to memorize this first one, and then the other ones, if you know how to derive it, you can just derive it on a piece of paper, okay? All right, so those are the three trigonometric identities, Pythagorean identities. Now, this one, a very similar question to this was on your test, right? And we did it using triangles. But now we're going to do it using using identities only. With each of these problems, you can use any of the identities we've learned until that point. Okay? Now, so this one, I have a cotangent, and I need to find sine and cosine. So this is the given, and I need to find these. Okay? Now, I have to draw the unit circle and figure out what quadrant we are in first. Some of you guys missed this on the test. So look at what this says. It says cotangent is positive. Where is cotangent positive? First and second.
Oh, wait, yeah.
I'm sorry, third. Okay, first and third. Here. Okay? Okay. All right. Then it says cosine is negative. Where is cosine negative? Second and third. So in what quadrant is all of our angles? Third quadrant. Okay? So remember, all of your answers have to have either a positive or a negative attached to it based on that quadrant. Okay, so let's see. So cotangent is what we have. We need sine and cosine. What identity relates cotangent to either a sine or a cosine? Yeah.
Cotangent squared theta plus 1 equals
Right,
cosecant
this
squared
one. Okay, and then I can just do the reciprocal. So that's how I start with. So I use cotangent squared theta plus 1 is equal to cosecant squared theta. Okay, so what's cotangent of theta? 2. This is cotangent squared, so 2 squared plus 1 cosecant squared theta. Okay, so this is 5 equals cosecant squared theta. Take a square root of both sides, And now cosecant theta is equal to, what happens when we take a square root of both sides? Plus or minus root 5. Okay? Now, we can't have two answers. We have to choose either the plus or the minus. In quadrant 3, is cosecant positive or negative? Negative. So I choose the negative one. Isn't that fun? Equals negative root 5 in quadrant 3. Okay? But that's all fine and well, but that's not what I needed. No, I'm just writing that so you guys know. I need sine and cosine. Okay, so what's sine then? Sine of theta is negative 1 over root 5. And now I need what? Cosine. Once you use, okay, you can use another Pythagorean identity for this, but once you use the Pythagorean identity once, see if you can use one of the other ones, like the quotient ones. So if I have a cotangent and a sine, I could use a quotient one, right? Because cotangent of theta is equal to cosine over sine. So cosine of theta is sine times cotangent of theta, right? So what's cosine of theta? Negative 1 over root 5 times 2, negative 2 over root 5. Okay, when you go home and you're doing one like this, you're going to be utterly confused because you would have forgotten everything we did here. Guess what you have to do? Open up your what? Yes. Okay, so here I think, so you're supposed to like multiply by sine and multiply by sine. I should have written that. So that's how you get what I got on the bottom. Okay? Huh? What? I couldn't hear you. Okay. Yep. I'm just hearing the word why without like a implementation of the question. Okay, Grayson, loudly. This? Because you have to find sine and cosine. Here we just found sine. Now you also have to find cosine. Okay, the question says find sine. It's two problems. Like
I keep on thinking about like drawing a triangle.
Yeah, no triangle. Okay, Tohar, what was your question?
If it's cosine theta over sine theta and you multiply by sine theta, how do you end up with sine theta?
So multiply by sine, this goes away, you have cosine, equal to sine times cotangent. So cosine equal to sine. I flipped it, I shouldn't have. I got, yeah. Okay. Yep.
Why do you multiply cosine theta like negative 1 over 5? Or negative 1 over root 5 times 2?
Because in order to find cosine, we said it equals to sine times cotangent. Right? This is sine, this is cotangent. Okay, were you saying something? Yeah.
Oh no, I'm telling
Okay. Maybe you can tell it after class, not when I'm teaching or listening to people. Okay. All right. So, cofunctions. Next type of identity. Okay. All right. So a cofunction is a trig function again that is related to another function. So we've never really talked about why is it sine and cosine, right? And tangent and cotangent. Like, what is that relationship, right? So here we go. This is it. In a triangle, we know that you have these two acute angles, right? Yes? The sine of one of these is always the cosine of the other one, right? We know this. How are these two related to each other? They add up to what? 90. So if you have sine of 40, that's exactly the same as cosine of the complement, which is what? 50. Okay? So if you have, for example, secant of 20, that's the same as cosecant of what? 70. Okay? Or if you have sine of theta, that's the same as cosine of, what's the complement? 90 minus theta, or pi over 2 minus theta. Okay? And that's how the Greeks defined cofunction identities. Yeah.
Do you still prefer radian over degrees?
Always. We're going to work primarily with radian. Okay? So here are all of the cofunction identities. So sine is cosine, pi over 2 minus theta, and so on. Now, notice it's pi over 2 minus theta, not theta minus pi over 2. Okay? Because that will be a negative difference, right? 5 minus 3, 3 minus 5, it's a difference of a negative, right? One you get 2, one you get negative 2, right? Why does that matter? Because we've already talked about this. Now we have the odd and even identities. What happens when you have sine of a negative theta? Remember we talked about this in one of the homework problems before, right? So if you have sine of negative theta, it's negative of sine theta, right? So it's like the negative comes out. But remember with cosine, so if you have an angle here, right? This is the cosine, and this is the sine, right? If you have the negative angle, the sine will switch, but what will happen to the cosine? Stay the same, right? So the cosines and the secants will stay the same, but tangent, because it's the combination of this, will also switch signs, okay? So how do I use this? I have sine of x is 4 over 5. What's sine of negative x? Negative 4 over 5. Okay, now I have cosine of pi over 2 minus x. What is that?
Pi over 2 minus 4. Is it pi over 2 over 1?
Well, okay, what's cosine of pi over 2 minus an angle? It's sine of the angle, right?
Wait, what?
Okay. Whenever you have cosine of pi over 2 minus an angle, it's the complement. Whenever you have cosine of this, it's the same as sine of x, right? Well, what was sine of x? 4 over 5. So this is 4 over 5. Yeah.
Okay. If you have cosine of pi over 2 minus x is the complement, which is sine x. If you have sine of pi over 2 minus x, would it equal cosine?
Yes. That's what it says over here in this box here.
Oh, got it.
Yeah? Okay. Now, take a look at this one. You have cosine of x equals this. Yep. Okay, so here, look at this one. Cosine of pi over 2 minus an angle is the same as sine of an angle. Yeah? So this is the same as sine x. But what is sine x in this problem? 4 over 5.
Would you ever be asked, like, would you ever have, like, a tangent there or something?
I mean, you can't go from cosine to tangent like that. So, yeah. Take a look at this one now. I have cosine of x equals this. This is what I'm given. So now, what is sine of pi over 2 minus x? This is equal to cosine of x, which is negative 0.75. Now take a look here. The difference here is, the difference with this versus this is the inside here is the negative of the other. It's switched, right? So now this will be, this is negative of, yes, this is negative of sine of pi over 2 minus x, which is negative cosine of x, so it's 0.75. Okay? because the inside is the negative. That's why in chapter 4, I assigned that problem with the theta and the negative theta. It's because we have to get used to that idea, and then now in chapter 5, we do this, right? So these are really, the homework problems are really not random at all. Yes?
So we take out a negative on that because that's
The negative of this. Yeah.
Oh, and then it becomes.
Yeah. Because if you have sine of a negative angle, then the negative comes out. Okay?
Wait, just because you took out the negative, why did they switch? Why did pi over 2 and x switch?
Because, okay, you know how 3 minus 5 is negative 2, right? But 5 minus 3 is the opposite. So 3 minus 5 is equal to negative of 5 over 3. What's 3 minus 5? Negative 2. What's 5 minus 3? 2. But you have to, but when you switch it, it becomes the negative. That's why here, whenever you have a minus sign and you switch these numbers,
You got that negative.
there's a negative. Yeah. And then if it's inside the sign, that negative comes out. Yes.
So shouldn't it be negative because cosine of x is negative 0.75
Right. Cosine of x is negative, but then there's a negative out here, and then it'll be positive.
But doesn't there's negative
No, it's cosine of negative x that doesn't change. It's when the negative is inside that it doesn't change. But here, that negative is outside.
Oh, so it's like negative.
Right, it's negative out. Okay, let's,
Like absolute value where like negative is about
kind of, yeah. Right, right. It's an even fun. Yep. Okay. So let's move on to this one. This is a whole other ball game. Now we're not going to get. Okay, you're going to miss very important stuff though. It's up to you. Okay, fine. Okay, so take a look. These now you're going to simplify, and your answers are going to be in terms of x's and a's and variables. Okay, so. Okay. This is always a tricky situation because when we learn here how to simplify these, it's kind of out of context. Later on when you use these, it's going to be inside of another problem. So you will know how far to go in order to suit your needs for that problem, right? So here, so it's almost like how far is simplified is simplified. You know what I mean? Okay, so, okay. So what I've decided is, basically, you want to make sure to rewrite it in terms of sine and cosine only, okay? But such that there are no other operations that you can do with it. Okay, so let's do one. For these, you have to use all of the identities that we have up above, okay? So now, so far we've learned like the odd and even, the Pythagorean, and all that stuff. So take a look here. I have 1 over cosine x. I'm going to leave that where it is right now. Then I have a 1 plus or minus with a trig function squared. Whenever you have a 1 added or subtracted to a trig function squared, you should immediately think Pythagorean identity. So which Pythagorean identity has the sine squared on the 1? That's the first one, right? So we're going to start with this one. Sine squared x plus cosine squared x is equal to 1. Now, these are not rigid things. You can manipulate them. You can move one thing to the other side and so on and so forth. So what I want to do is I want to change this around so that it looks like 1 minus sine squared x, right? To do that, I'm going to subtract sine squared x. So what I get is cosine squared x is equal to 1 minus sine squared x. Everybody agree with that? Okay, now look at what I have here. 1 minus sine squared x. What is that the exact same thing as? Cosine squared x. So what I do is I replace this with cosine squared x. Okay? So I already have the 1 over cosine x, that didn't change, times cosine squared x from that box.
So,
Yep, yeah,
That's correct. So you use the what's it? I get the.
Pythagorean identity.
Okay, I was just thinking.
How did you get from cosine squared x equals 1 minus sine x to?
Because what's cosine squared x the exact same as? 1 minus sine squared x. Here.
Right.
Okay, and then this is 1 minus sine squared x, so you just
Isn't it pi
replace.
over 2?
No. No, you're getting confused. So now look, you have 1 here, 1 here. This just reduces to cosine of x. Okay?
One squared.
Yeah,
One of
it's like
the-
x squared over 1. Because you have, what you have here is, you have like cosine squared x over cosine x, right? And it's just like having x squared over x. You cancel 1 with 1, right? And you get cosine x. Yes, Ben?
How does 1 minus x squared x equal cosine squared x?
Okay, do you see how we start from this?
Yes.
I subtract sine x, sine squared, I
So
subtract
then you
sine.
just left with cosine squared x equals.
Right,
Oh, so you
Right.
Oh,
right,
you just, oh, because you now have an individual.
right. Okay, now this one. Here I have cosine and sine, but I also have a tangent in there. Whenever you have a tangent in there, one thing you can do is rewrite it in terms of sine and cosine. So I'm going to rewrite this as cosine of x times sine x over cosine x minus sine x cosine squared x. Now you can get rid of this cosine and this cosine. And then always rewrite them. So now I have sine x minus sine, hang on, sine x cosine squared x. Okay? So I cancel, and then I rewrite. Now,
But you can't subtract those, right?
no, now, they're not like terms, so you can't subtract them. However, I have a sine x here in this term. How many terms total are here? 2 terms. I have a sine x here and I have a sine x here. I can factor out a sine x. So I factor out a sine x. When you factor out a sine x, what do you have in the first term? What do you have left in the first term? A 1 minus cosine squared x. Now again, we have a Pythagorean identity situation because we have a 1 with a trig function squared. So it's how much? Sine squared x. Yep. Okay?
You're missing, you forgot about 1 over sine x.
No, I factored it out.
Would you just do
Sine cubed x.
times
Yep.
sine squared x?
Right. So this is sine x times sine squared x sine cubed x. Okay.
Wait,
Okay.
1 minus
Hang on. So look at this Pythagorean identity here at the very top. Sine squared plus cosine squared equals 1. How about, okay, I have sine squared x plus cosine squared x equals 1. Okay, let's subtract cosine squared from both sides. What do I get? Sine squared x equals 1 minus cosine squared x, right? So what I've done here is I've basically put in one type of, one example of each type of problem you'll get. So this one, you have a fraction that's being added or subtracted. When you have 2 fractions that you're adding or subtracting, you have to make a common denominator, right? Now, the common denominator here is going to be 1 minus secant x, 1 plus secant x. Okay, so remember, how do we do that? So we're going to multiply this first fraction by 1 plus secant x, right, top and bottom, and then 1 minus secant x, top and bottom, right? Okay, so what do I get inside here then? I'm going to get 1 plus secant x This is like a beautiful problem. Times secant x plus or minus 1 minus secant x secant x. Okay. Okay. Now we're going to distribute. Now we're going to distribute. I can't wait too long.
You can cancel out?
No, don't cancel. Now we're going to distribute. Okay? When you distribute, you get secant x plus secant squared x minus secant x plus secant squared x.
Wait, this is weird. Oh, minus.
So then minus, there's also a minus
Right.
here.
So the minus gets distributed and the 1 plus
Right.
secant x
Right.
gets distributed. Okay.
Over, what's this business?
1 plus or minus.
1 minus secant squared x. Because remember, right, if you have a minus b, a plus b, you square both and subtract. Okay, now what happens? Secant x minus secant x go away. What am I left with? Secant squared plus secant squared is how many secant squared? 2 secant squared x, because they're being added. Over 1 minus secant squared x. How much is 1 minus secant squared x these days? Really? Let's go to the identities. What's 1 minus secant squared x? Is it tangent or negative tangent?
What? It's negative tangent.
It's negative tangent. So look. Okay, so look.
This is like exact.
So look, tangent squared x plus 1 is secant squared x, right? 1 minus secant squared x means you have to bring the tangent to the other side. So this is negative tangent squared x. But look, we're not done yet because it's not in terms of sine and cosine. This is 2 times what's secant? What over what? 1 over cosine squared. What's tangent? Sine squared over cosine squared x. Now what happens? What cancels? The cosines cancel. So what do I have? Negative 2 over sine squared x. And that's fine. Huh? Yeah. Yeah. Yeah.
Why do you have to switch from 2 secant squared x over negative?
Because we agreed that for it to be simplified, it has to be in terms of sine and cosine.
And then we get to this one. I'm like,
Yep.
if this is supposed to be a fun one, what are the other ones supposed to be?
Okay.
So like for the next.
So you know how we have 1 minus secant squared
Oh,
here?
that's tangent. Okay.
So this one will just be. Yeah, when did you guys?
I'm doing math here. Yep. Okay. Okay. 1 minus secant squared.
Yeah. Oh, that's tangent.
That's negative tangent.
Oh,
If
okay.
you, yep.
How is it the square x plus this square x?
It's an identity. Here.
So we just
It's that identity.
So we just have to.
You just, it does make sense. We derived it. Look, we derived it. Remember, we started with this, divided everything by cosine, and then we got this.
So are we?
Okay, yep, and then I need to move on.
How do we know which identity to use?
So you have to see which one has the stuff you need. For example, like this one here, right? This one has a 1 and a secant squared. So look at which one has a 1 and a secant squared in the same equation. So look at this next one here. I have a 1 plus tangent squared. Which identity has a 1 and a tangent squared? This one, and it's already in that form, so it just equals secant squared x. Over cosecant squared x. But what's 1 over, what's secant?
1 over cosine.
1 over cosine squared x. Cosecant is 1 over sine squared x.
So it just equals.
And then look, sometimes when my mind is tired, I write it out like I did in elementary school. You know, dividing two fractions means the first fractions times the reciprocal of the second. There's nothing wrong with that. There's nothing, look at all the fancy math I'm doing. It's okay. I can go, you know, rudimentary for a little bit, okay? So what's sine squared over cosine squared? Tangent squared x, right? Because the important is to get the important thing is to get the right answer. It's not, I mean, the important, no.
Yeah, that's
Huh?
what I was gonna say.
Oh, yeah.
So it should say.
Either way will be okay.
Sine squared x over cosine.
Why do you have to simplify secant and keep cosine? Right, I mean,
Next one's easier. Huh?
That's easy.
Huh?
cosecant and secant not simplified. Like, why did you have to go one over?
Because we've agreed that with the simplified form has to be all in sine and cosine.
Oh, it can't be.
Right, so I mean, I
should just keep it in.
just, yeah, sine over I mean, that part I wouldn't care. As long as there are no other operations hidden inside, it's
It just
okay.
doesn't seem as satisfying when you leave it.
I know, you're right. Yeah. I'll get you in a minute, hang on.
Is not, we don't change it to tan?
You want to keep it in terms of size.
Oh, yeah, you said that.
Okay,
So we don't have to.
let's go back to algebra 2. Okay, so listen. In algebra 2, we learned that if you have, okay, look, in algebra 2, we learned that if you have ln of a plus ln of b, that's ln of a times b, remember? And then we learned ln of a minus ln of b is ln of a over b, correct? Then we also learned if you have ln of a to the power of n, what happens to the exponent? It moves down and becomes n ln of a. You guys remember that? Okay. So here, I have, who cares what a and b are? It could be ln of 3 and ln of 5. It could be ln of sine and ln of cosine. So it's ln of tangent of x. That's it, right? So it's just ln of sine x over cosine x. Now, okay, so let's think about this. Let's put this absolute value here. And then this is ln of tangent x. Now look, I know we said sine or cosine only, but there is no, it's not a big deal if you write sine over cosine as tangent. So let's think about this. Hang on, please. We know that the stuff inside the ln always has to be positive. You can never have ln of a negative number. So now you have to think to yourself, here we have ln of tangent. In its lifetime, is it ever possible for tangent to be negative?
Yes.
Yes, because it crosses below the x-axis. That means you must keep it in absolute values. Okay? So now, hang on, before you leave, hang on. Listen. If you have ln of cosine squared x, cosine squared is always positive, right? No need for parentheses. But that's not fully simple. No need for absolute value. But that's not fully simplified. The 2 has to come down, and then you do have to put it in absolute values. You see that?
When we have an ln, will it be absolute?